The Sun is a star located at the center of our solar system. It's a massive ball of gas, mostly composed of hydrogen and helium, generating energy through an intense series of nuclear reactions. The Sun is approximately 4.6 billion years old and is typically in a phase that will last about 5 billion more years. It has a diameter of about 1.4 million kilometers, approximately 109 times larger than the diameter of Earth. The pressure and temperature at its core create thermonuclear fusion reactions that convert hydrogen into helium. The Sun is a massive fusion reactor producing an incredible amount of energy every second. This energy production originates from the thermonuclear fusion reactions within the Sun. The amount of energy the Sun sends to Earth every second is quite impressive. The light and energy from the Sun reaching Earth corresponds to an average of 1,370 watts per square meter in space outside the Earth's atmosphere. The Sun converts approximately 600 million tons of hydrogen into helium every second. In this conversion process, about 4 million tons of mass is converted into energy every second. Only a small portion, approximately 0.7%, of the Sun's total mass converts into this energy production. Throughout its life, approximately 4.6 billion years, the Sun has produced an incredible amount of energy by converting hydrogen into helium. The Sun, with its continuous fusion process, remains a massive energy source that will continue to produce energy steadily for billions of years. This energy supports the heating of planets in the solar system, atmospheric events, and sustains life. Sunspots are relatively dark and cold areas on the surface of the Sun. They usually appear darker due to being cooler and reflect less light than their surroundings. Sunspots are associated with the Sun's magnetic activity. Sunspots are a complex result of the Sun's magnetic field. They form due to intense magnetic activity within this field. Areas with more intense magnetic fields become visible as spots on the solar surface. When observed, they usually appear as dark centers surrounded by lighter regions. They have lifespans ranging from several hours to several months. Some large spots can be observed for weeks or months. Sunspots vary within the Sun's activity cycle, which typically lasts about 11 years. Leading to fluctuations in the number of spots, the Sun affects the orbits of planets and atmospheric conditions through electromagnetic radiation, magnetic fields, and solar winds. The Sun plays a critical role in the existence of life on Earth. It influences the balance between planets and the formation of life in the universe. It is also of great importance in fields such as astronomy, space exploration, and solar energy. Magnetosphere and atmosphere. Solar winds interact with Earth's magnetic field, known as the magnetosphere. This interaction leads to changes in the magnetosphere and creates auroras, light displays, in polar regions. Solar radiation. Radiation from the Sun leads to chemical reactions in the atmosphere, influencing surface weather conditions and climate. Sun's magnetic field. The Sun is surrounded by a magnetic field. The Sun's magnetic field is the source of magnetic activity on its surface, Earth's magnetic field. Earth also has its own magnetic field, protecting it from charged particles coming from the Sun, and is called the magnetosphere. Magnetic fields have a significant impact on the atmospheric conditions of the Sun and planets. They create a supportive environment by preventing the entry of charged particles into the atmosphere and can produce visual displays like auroras. The magnetic interactions between the Sun and planets are essential for space weather studies and solar activity research. The Earth's rotation around the Sun is a fundamental characteristic observed in many of the planets in the solar system. This rotational movement occurs as the Earth rotates around its own axis. The Earth's orbit around the Sun, orbital and rotational movement. Earth orbits the Sun, creating a rotation that results in a year lasting about 365.25 days. Tilt and effects. the tilt of the Earth's axis plays a significant role in the formation of seasons. The axis tilt changes the Earth's position relative to the Sun and alters the angle of sunlight, leading to changes in seasons, day and night. The Earth's rotational movement creates the cycle of day and night. Different parts of the Earth face the Sun, leading to daytime in those regions and nighttime when facing away. Division of a year. The Earth's rotation results in changes of seasons and varying weather conditions over a year. These periods are related to the Earth's movement around the Sun and its tilted axis. The Earth's orbit around the Sun, orbital and rotational movement. Earth orbits the Sun, creating a rotation that results in a year lasting about 365.25 days. Tilt and effects. The tilt of the Earth's axis plays a significant role in the formation of seasons. The axis tilt changes the Earth's position relative to the Sun and alters the angle of sunlight, leading to changes in seasons, day and night. The Earth's rotational movement creates the cycle of day and night. Different parts of the Earth face the Sun, leading to daytime in those regions and nighttime when facing away. Division of a year. The Earth's rotation results in changes of seasons and varying weather conditions over a year. These periods are related to the Earth's movement around the Sun and its tilted axis. The Earth's rotation around the Sun forms the basis of many natural events. Day and night, seasons, climate, and even plant and animal life are shaped by this rotational movement. This rotation is crucial for the continuation of life and diversity and is one of the fundamental elements shaping our planet's dynamic structure. Don't forget to subscribe to our channel and like our videos, kids.